Hi, I'm going to talk about esdiscuss.org today, which is a Node.js application I've built over the last couple of years. There's not going to be any code in this, so it's not helpful to have any prior knowledge of JavaScript, and you won't get any knowledge of JavaScript from this talk. But I'm just going to talk about how it's structured, because it's kind of an interesting little app. So the goal is to take what's on the left and turn it into what's on the right. What's on the left is an archive from Pipermail. So it's produced by an email archiving system. esdiscuss is a mailing list. People send emails. This system archives them so you can read them later. And Mozilla hosts the one on the left, which is a plain text archive. There is no CSS, no style sheet for this. It is just, as it comes, plain raw text. And that's kind of ugly. And it only shows one message per page, which means you have a link to click every time you want to see the next message. Since actually quite a lot of people read these things and go to this page, I thought it would be nice if it was a bit easier to read, a bit clearer, if it had syntax highlighting, formatting, and showed more than one message on a page. So the goal is to turn it into what's on the right, which is how it looks today, which is a threaded conversation. You get syntax highlighting, and you have avatars and the like. So my first version of this reads messages from Pipermail, parses the HTML to get the raw text of the message out, and then renders the HTML to some kind of formatted version. It did this on a per message basis, which means that we only show a single message. We weren't able to show those threaded conversations. So this wasn't really good enough, but it was a first proof of concept. This went live. A few people looked at this. A few people liked it and were keen on it, but ultimately not having the threading of conversations was a deal breaker. Next up, I try parsing the whole of the Pipermail archive. I try and generate threads based on the email subjects, and then I generate a static HTML site. So this was quite nice. I now had threaded views. I could now build up that formatted layout. But initially I was doing this as a static HTML site. So this took of the order of about half an hour to rebuild the entire site by drawing everything down off of esdiscuss, of the Pipermail archive, and rendering it to real HTML. And doing that every time I wanted to test out a new style and change something and see if it worked better or worse wasn't really an option. And it also meant that we couldn't fix people's formatting. There wasn't any store of the messages in which we could fix the formatting of messages. So sometimes people send something and something that should be a code sample, they haven't appropriately marked it as a code sample, and then it doesn't get syntax highlighted as code, and that looks really ugly. And it's nice to have a few admins, moderators, who can come in and edit them and say, that bit was a code sample, so it should look like code and should be highlighted. So to fix this, I decided that I needed to make the architecture more complicated again, because more complicated is better with these things. So I needed some kind of collaborative editing tool, and I thought Git and GitHub already provide that. So what if I store the messages that I get off Pipermail in GitHub? Simple editing interface, simple peer review system. So now I'm reading from Pipermail. Turns out they have a text-based archive as well as the HTML archive, so that was easier to parse, a bit faster. So I used that this time. I cache the threads, initially to the file system, but later to a MongoDB database. And I store the messages in GitHub, and then the website itself, in real time, as you browse the pages, reads the messages from GitHub and reads the threads from MongoDB to compile the page. That meant page renders could be done sort of in real time-ish with a lot of caching. It took sort of 10 seconds to render a page for the first request, but then if you requested it again, it could just render it from the cache. But that caching turns out to be a pain, so there's a lot of problems with this. So some of the problems: Git as a command line tool wasn't available on the server that I was running it on. So I solved that problem by learning about the GitHub API. So I did it via the GitHub API, the web requests. That worked. But regardless of whether you use Git or the Git command line tool or GitHub's API, committing to GitHub is really, really slow. So it took of the order of an hour or so for new messages to appear, just because of the slowness of committing messages to Git. Reading from GitHub is also really slow, so that meant really long cache timeouts, because if you didn't hit the cache, you were going to be waiting 10 or 20 seconds sometimes, and that's not really acceptable. Combine that with only, say, 100 visitors per day, and even with cache timeouts of half an hour on each page, there's a good chance you're getting a non-cached copy, in which case it's really, really slow. There's another big problem. I'm reading the text archives now, not the HTML archives of Pipermail, and for some reason they don't support Unicode, so instead of any Unicode characters we just get a question mark, which turns out to really suck when you're talking to an international audience and some people have umlauts in their names. And then the other problem I had was the server crash frequently. So the architecture I had at the beginning was one server, because servers cost money, with effectively two apps on it. One that polls for updates and commits those updates to GitHub, and one that serves the actual website. It turns out that polling for updates and doing lots and lots and lots of network activity continuously, including work with Git and GitHub's API, turns out that's quite difficult to make stable and reliable, and that tends to crash from time to time. So initially I had that in a situation where that crashing could bring down the whole website and the whole thing would crash. So this led to fairly low reliability. Now what I have is two servers. One polls for updates, one serves the website. A little bit more expensive, but now we're seeing uptimes on the website of the order of 3 to 4 nines, and on the server that does the polling, we're seeing uptimes of around about 80%. But that's fine, because it goes down for an hour or so on average per day, and then it catches up as soon as it comes back. And this is a perfectly sustainable situation. So because it passes the last 2 months, near the beginning of any month, it's only passing about 30 days of messages each time, and it stays up for 90% of the time, goes down for maybe 30 seconds to a minute per day. Towards the end of the month, it's passing 60 messages each, with 60 days worth of messages each with each run. And then it tends to go down for about an hour to 2 hours per day on average. So not great uptime, but fine because it's just polling for updates. So now we're reading messages from Pipermail. We're parsing the HTML because we want Unicode support. And we're storing messages in MongoDB because Git's way, way, way too slow for us. We have a separate thing that runs as a second task once we've done that just runs a simple aggregate query over all of the messages to extract the threads, and then we do that on the polling server and store it in a collection so we don't have to run that relatively expensive query every time a page loads. Then on the website, we have a really, really simple system. We read data from MongoDB and we render a web page. The advantages are we no longer need those long caches. This system now does caching for like a second or two and then refreshes. That turns out to be much simpler. Caching's horrible and complicated. It doesn't go down when the polling server crashes. MongoDB is really fast, so most of the time updates appear within a few minutes. And we can have a custom editing GUI. It turns out not to be that difficult to build an editing system for plain text for small messages. Probably wasn't worth farming that out to GitHub, but it was a quick fix at the time. So we now have this listing page that shows you all the threads, and then you drill down into that and you get a page with the actual message on it. So lessons I've learned from this: it's possible to automate pretty much everything on GitHub. They have really good APIs. They're a little bit complicated to drill down into, but you can automate everything. But GitHub's really slow as a database. Sometimes data has to be streamed, so I had part of the reason the polling server goes down is because it runs out of memory because it tries to download too many messages in one go. So one of the nice things about Node is you can encourage it to stream, so it just processes a couple of messages at a time, and then that way it doesn't run out of memory. Never do batch processes on your web server if you can avoid it. It tends to be a lot more likely to fail, a lot more likely to make the server crash. I'm Forbes Lindesay. Thank you for listening. Cool.
Any questions for Forbes?
I've got a question.
Yep.
Why did you have to put two actually separate boxes in order to stop them crashing each other? They just be isolated in some way.
So the reason that one of the servers crashes on a fairly regular basis is because it runs out of file handles on Unix. And I think, as far as I can work out, those are a shared resource across the entire server, and it's relatively difficult to isolate them. I mean, it's two virtual machines. They're not necessarily, I don't know whether they probably do end up on separate boxes because they're all cloud hosted, but they're not. I haven't gone out and bought two physical boxes. Yep.
Can you use ULimit to?
Can I use what, sorry?
ULimit to ring fence it.
It's because it's on quite a simple hosting provider. I don't think there's necessarily.
You don't have room.
I'm not sure what I can. Yeah, I'm not sure how much of that sort of permissions I had. And actually, it's costing an extra $10 a month. People donate about $14 a week to me to host this. So the costs stack up. It doesn't really make sense for me to spend a whole day fussing around making it work on one server. Yep.
Did you, by any chance, try Redis with Mongo? Like Redis versus Mongo?
So looking at this, there's a free MongoDB hosting provider, which means that it's up to a 500 megabyte database is free. So that performs really plenty fast enough. So that cuts down on hosting costs. But on the other hand, it's storing around 25,000 messages, which works out at sort of 40-50 megabytes once it's all in the database, which is fine on a sort of more traditional database or something like Mongo. But Redis, because it stores everything in memory, Redis seems to scale in cost really, really rapidly, and the kind of performance of an in-memory database just wasn't needed. It's also not doing any real-time updates because it's polling for the messages, so they take about 5 minutes to go around the polling sequence. I didn't really see much point in making the UI have push updates.
Thanks, Paul.
Thank you.